Welcome to this video. Today we are going to talk about aerotriangulation in DJI Terra. We have three topics to cover. The first one is the parameters under aerotriangulation. The second one is GCP. And the last one is ROI. Aerotriangulation is crucial when creating 2D maps and 3D models in DJI Terra. During this process, the DJI Terra identifies the common points from the overlapping images taken by the drone, and then calculates the exact position of each point. After that, you will get an accurate and detailed point cloud, which is a set of data points in the space. This point cloud is the foundation of generating the final 2D map or 3D model. Let's look at some settings in DJI Terra about the aerotriangulation. The first one is Scene. Open DJI Terra, create a visible light mission, and import photos. Then, you can set three different scenes under the aerotriangulation. The first one, Normal, is suitable for most mapping missions, including the ortho and oblique missions. Circle is perfect for vertical structures like communication and power towers or wind turbine, using the drone flying around them. In this case, DJI Terra will automatically limit the ROI of result within the surrounding range. Power line is used for power line scenario and will only generate the point clouds for 3D model reconstruction. The drone can fly using a Z-shaped flight path. Under feature point density, it's recommended to maintain high, which is suitable for scenarios that require high accuracy and quality in results. On the other hand, using low can speed up the reconstruction, but may sacrifice the quality and accuracy. Distance to ground is the distance between the camera and the ground or subject. If multiple distances exist, use the shortest distance for calculation. The larger this value, the longer the computing time. The default value applies to most scenarios. The output result of the aerotriangulation will be DJI Terra format by default. You can enable XML, which will generate blocks exchange format, and you can define its coordinate system to work with third-party model repair software. It is recommended that the coordinate system be consistent with the 2D and 3D reconstruction coordinate systems. Next, we are going to talk about GCP. GCP, which is ground control points, are physical, marked points on the ground with known coordinates and are clearly visible in the image. They can be used to correct the potential errors, and you can use them to optimize the accuracy of the aerotriangulation results. You can also use them as checkpoints to check the accuracy of the result. Before using the GCP feature, please prepare a file containing GCP coordinates. You can also manually enter the numbers when creating GCPs. The information in the GCP file should follow each line from left to right, respectively, for name, latitude, longitude, altitude. Horizontal and vertical accuracy for optional. It is recommended to separate them with space. After completing the photo import and related settings, click on GCP Management under the Aerotriangulation and Advanced to enter the setting interface. Before importing GCP file, please select the coordinate system of GCP first. If the coordinate system is special, you can choose arbitrary. You can set unsupported geoid as the default. In the GCP list, click Import Mark File or Import GCP File to import the GCPs. Import Mark File only supports JSON files exported by DJI Terra. During the import, if DJI Terra cannot automatically recognize each item, please adjust the column separator. If you need to add or delete a GCP, click on the plus or minus button in the GCP list to operate. In the GCP list, select a GCP, and you can edit its information below, such as GCP type, editing the horizontal and vertical accuracy, and setting the coordinates. When checkpoint is selected for the type, it will not participate in the data correction, but will be used for accuracy checking. The next step is marking. Before marking, you should run the Aerotriangulation first. After the completion, Aerotriangulation results will be include camera attitude and point cloud displayed on the left. Select any GCP. Turn on the option Only display photos with GCP. Click on a photo that contains this GCP and the marking view will appear on the left. The blue crosshair represents the predicted position of the GCP. You can complete manual marking by clicking the actual location of the GCP with your mouse. Using the auto-identify function can greatly improve the marking efficiency. After the first marking, the auto feature will mark other photos by itself. The marked GCP will be displayed in green color. For pictures where marking is completed, there will be a checkbox symbol showing manual or auto markings. Click on the delete icon above to remove the marking information from that photo. Under the information about GCPs, reprojection error and 3D point error also update accordingly. These two values can be used to judge the accuracy of GCPs. They change color between green, yellow, and red, with green being the best result. If constraint with image post data is enabled, the post data of photos will be used in the optimization process. If it is not enabled, calculations will be based entirely on the GCP information. Using at least 4 evenly distributed GCPs in the survey area is recommended. Each GCP should have at least 4 marking photos, with locations as dispersed as possible and making the positions avoiding photo edges. After completing all markings, click the Optimize button to perform recalculation. Upon completion, an Aerotriangulation report will be generated. You can click to view it. Click the Export GCP button to export the current GCP and marking information into a JSON file. Next, let's talk about ROI, region of interest. Before 2D or 3D reconstruction, users can set a region of interest after adding photos, which will save time, improve the efficiency, or smooth the model's boundary. Pay attention to the fact that you must finish the Aerotriangulation before setting ROI. Open the 2D map or 3D model tab, Advanced, and click Region of Interest. There are 4 ways to create ROI. First is Auto. Click Auto or Max, and DJI will recognize the boundary automatically. This is the fastest method. Second, KML import. Click Import KML and select the KML file containing only a polygon shape. DJI Terra will transfer it to the boundary shape. Don't forget to set the height afterward. Third, input coordinates values. You can manually enter the maximum and minimum latitude, longitude, altitude, or XYZ, then click Apply to set the ROI. Fourth, manually creation. You can also click on the map to create the ROI region by yourself. Enter the editing mode. Click to create the shape and drag the points for adjustment. Then edit the altitude for the height adjustment. After finishing, click Save. You can copy the ROI to 2D or 3D reconstruction to save time. After the ROI is set, click Apply. You can rotate the model for an overview. Block splitting under 3D reconstruction allows you to change the size of a block depending on your computer's memory. You can change the block splitting mode to auto, custom memory size, or custom length. That's all for today's topic. Thanks for watching.